In this tutorial, we will learn about titration calculations. In a titration, we always have one solution with a known concentration. This solution will usually be in the burette. Then we will place the other solution, which has an unknown concentration, in the conical flask. The volume of the solution is transferred into the conical flask using a volumetric pipette, and this will ensure the accurate measurement of the volume. Let's take an example. In this titration experiment, 20 cm³ of the potassium hydroxide solution was placed in a conical flask. So inside this conical flask, we have 20 cm³ of KOH. And then a few drops of phenolphthalein, the indicator, were added to indicate the end point of the reaction. It was titrated against dilute hydrochloric acid, HCl, whose concentration is 1.00 mol per decimeter cube. The titration was repeated until two concordant results, which means that they are within 0.1 centimeter cube of each other, were obtained. So in this experiment, it was found that the potassium hydroxide solution reacted completely with exactly 12.5 centimeter cube of the dilute hydrochloric acid added from the burette. So we have to find the concentration of the potassium hydroxide solution. First of all, keep in mind to start with the balanced simple equation for the reaction, which is KOH plus HCl will produce KCl and H2O. The concentration of the acid, which is HCl, is known, and it's equal to 1.00 mol per decimeter cube. On the other hand, the concentration of the alkali, potassium hydroxide, KOH, is unknown. We want to find the concentration of the alkali. Please note that in your exam, you may be asked to find the concentration of the acid or the concentration of the alkali. In this exercise, we will find the concentration of the alkali. But of course, you'll need to do the same calculations if you are asked to find the concentration of the acid. The volume of the alkali in the conical flask is 20 centimeter cube, and we have to convert it, of course, into decimeter cube. So we will divide by 1000, and this is equal to 0.02 decimeter cube. On the other hand, we will take the average volume of the acid, which was needed to neutralize the alkali, and in this case, it's equal to 12.5 centimeter cube. Again, convert to decimeter cube, so it's equal to 0.0125 decimeter cube. So we know the concentration of the acid and the volume of the acid. Let's find now the number of moles of the acid, which is HCl. To find the number of moles, we will use this equation. The concentration in mole per decimeter cube is equal to the number of moles divided by the volume. And thus, to find the number of moles of the acid, we will multiply the concentration by the volume. So the number of moles of the acid is equal to C times V, 1 times 0.0125. Don't forget to use the volume in decimeter cube, and this is equal to 0.0125 moles. Now we have to find the number of moles of the alkali. Let's examine the balanced equation again. The balanced equation shows that KOH and HCl will react in a 1-to-1 ratio. And this means that the number of moles of the acid is equal to the number of moles of the alkali. And therefore, the number of moles of the alkali is 0.0125 mole. So now we know the number of moles of the alkali and the volume of the alkali. All we need to do now is to calculate the concentration. So the concentration of the alkali will be equal to the number of moles divided by the volume. So it's 0.0125 mole divided by 0.02 decimeter cube, which is equal to 0.625 mole per decimeter cube. You may be asked to find the concentration in gram per decimeter cube. So you have to convert the concentration from mole per decimeter cube to grams per decimeter cube. So we found that the concentration is equal to 0.625 mole per decimeter cube. Notice that both of the concentrations are given in decimeter cube. So actually we don't have to worry about the volume. All what we should do is to convert this number of moles into the mass. This formula shows that the number of moles is equal to the mass divided by the relative atomic mass AR. If we rearrange this equation to find the mass, we will find that the mass is equal to the number of moles times the relative atomic mass AR. In this case, we have to find the relative formula mass of KOH, which is equal to 39, the relative atomic mass of K, potassium, plus 16, the relative atomic mass of oxygen, plus 1, which is the relative atomic mass of hydrogen. And this is equal to 56. So now let's find the mass. The mass will be equal to 0.625, which is the number of moles, times the relative atomic mass, which is equal to 56, and this is equal to 35.0 grams. And this means that if we have 0.625 moles in decimeter cube, this is equivalent to 35 grams in decimeter cube. So the concentration is equal to 35.0 grams per decimeter cube.